All right, so let's answer this one. This is AQA GCSE calculator, June 2023. So let's go straight into it. So number one, write 30, sorry, 30 ratio 12 in the form of n ratio 1. So very simple. You can see that the 1 is in the same position as the 12. So what do? You divide both of them by 12. Okay, so 12 divided by 12 now give you 1. And then 30 divided by 12, you can use your calculator quickly. It should give you somewhere around 2.5. So your answer will be 2.5 ratio 1. Yes, it's a decimal, but they specifically ask for in the form of n ratio 1. So yes, your answer will be 2.5 ratio 1. Okay, so why did I divide, these two numbers by 12? Because of what they asked. Okay, so I'll go over it again. We have 30 ratio 12, and they said in the form of n ratio 1. So you have to follow the order. Okay, and for this one, we have 1 and 12 are in the same position. So it means we divide both sides. Like, how do we get 1? Divide 12 by 12. Okay, you also divide this by 12. This gives you 1, and this gives you 2.5. So your answer is 2.5 ratio 1. So supposing the question had said, oh, in the form of 1 ratio n, we still have to follow the order. So it'd be something like this. It will be, okay, we have 30 ratio 12, and then 1 ratio n. We follow the order. So we want to get 1, we divide both sides by 30. This becomes 1 ratio 12 divided by 30. 12 divided by 3 is 4. This should give us 0.4. That is if the question was 1 ratio n. So there's so many ways, I think there's so many ways questions like this can come up, but I hope I've been able to kind of explain it well. Now, number two, four consecutive triangular numbers. So let's talk about triangular numbers quickly. What are they? Now, these are, I'll just call them dots like this. Now I have what, one, two. You can see I've formed a triangle. One, two, three. You are forming equilateral triangle. So you have, three dots here, three dots here, three dots here. You have formed an equilateral triangle. Okay, you keep going. Okay, I can do four dots now. One, two, three, four. You can see we have four dots here, four dots here, four dots here. So we just keep going. We do five. One, two, three, four, five. Or from another equilateral triangle, five dots here, five dots on the base, and five dots on this side. So these are triangular numbers. So if you count each triangle, like the first triangle, how many dots do you have? You start from one first, obviously. And then this is three. Let me erase these lines first, and these lines. Okay. Okay, you have three. Okay, for the next one, the next triangle, you count the number of dots. You have one, two, three, four, five, six. You have six. For the next one, next triangle, you have from six, now you have seven, eight, nine, 10. Okay, the next one from 10, 11, 12, 13, 14, 15. So these are what we call triangular numbers. Okay, so triangular numbers are 1, 3, 6, 10, 15. How do I get, okay, so supposing I don't want to have to draw the triangle again, how do I get to the next number? Okay, we added five dots before. Now we just have to add six dots. That will give us 21. Okay, and then there's also a formula that we can use, n bracket n plus 1 over 2. Supposing they ask you to find triangular numbers. So let's look at the question. Four consecutive triangular numbers, 6, 10. Oh, we already have them here. 6, 10, 15, and 21. Write down the next triangular number. Okay. So in order to do this, the easiest way is ask yourself, how did I get from 15 to 21? What did I add to 15 to get to 21? I added 6. So it means that the next one, I'll just add 7 to get 28. So the next The next triangular number is 28. Okay. There's still another way to do it though. But the next triangular number is going to be 28. If you look at this triangle, okay, this is 5. One, two, let's do 6, 3, 4, 5, 6. So 15 plus 6 gives us 21. And we do another triangle. So this is how you do triangular numbers. It's actually um very easy. Now, another thing you should know, let me also add this, is that the sum of two triangular numbers is a perfect square. Okay, the sum of two triangular numbers is a perfect square. So look at it. Let me use a different color now. 1 plus 3 is 4. 4 is a perfect square. 3 plus 6 is 9. So let me just substitute, which is 2 square, 3 square. 6 plus 10 is 16. You can see how this is, which is 4 squared. 10 plus 15 is 25, which is 5. So it means that when you add two triangular numbers together, it gives you a perfect square, which is very interesting. Like it gives you a perfect square. And you can also use that to find the next triangular number. That's what do I mean? Now, supposing you have still this, so we got our answers at 28, okay? Supposing you wanted to use that fact that two triangular numbers add up to a perfect square. Okay, we have, let's say we have 6, 10, 15, 21, x. All right, so like we said, we could just add 7 to it, right? But we can also say, okay, hmm, 15 plus the 21 is what? So look at the first, the one, the number before the 21 is 15. 15 plus 21 is what? That gives us 36. So it means that if I add 21 and the next number, it should give me the next perfect square, which should be 49. Because this is 6 squared. The next, if I add 21 and the next triangular number, it should give me another perfect square, which should be 49, which is 7 squared. And what is 49 minus 21? 9 minus 1 is 8. 4 minus 2 is 2. 28. So you can see that this is how you can, answer questions on perfect square. All right, so I hope I made that perfectly understandable. Number 3, write down the reciprocal. When you hear the word reciprocal of a fraction, turn it upside down. Turn it upside down. So the reciprocal of 4 over 7 becomes 7 over 4. Or you can rewrite this, I can write this as 1 whole 3 over 4. I think 7 over 4 will be okay. You just write it like this. It'll be fine. Okay. Let's look at other examples. They ask you for the reciprocal of, let's say, 2 over 5, which would be 5 over 2. Reciprocal of 10 over 3, it will be 3 over 10. What if they ask for the reciprocal of 3, for example? A whole number. Okay. The first thing, so a whole number, you can rewrite a whole number as that number over 1. So 3 over 1, and then you flip it as 1 over 3, or turn it upside down as 1 over 3. So usually when they ask you for the reciprocal of a whole number, you just have to make it 1 over that number. Reciprocal of 12, for example, 12 is the same thing as 2 over 1. Turn it upside down, you have 1 over 12. Okay. If they ask you for the reciprocal of a mixed fraction, example, 1 whole number, 2 over 5, for example, turn it into an improper fraction first. So this is 5 times 1 is 5 plus 2 is 7 over 5. Then turn it upside down. That gives you 5 over 7. So whenever they ask you about the reciprocal of a fraction, turn it upside down. Okay. So sometimes the question might also, so instead of just asking for the reciprocal, it might be something like this: 4 over 7 to the power of -1. So anything to the power of a -1 is also asking you the same thing, the reciprocal of that number, which will still be 7 over 4. All right, or 1 whole 3 over 4. All right, so let's move on to the next question. Okay, what's the next question? All right, no, number 4, the price of a toy increases by, okay, let's say the price is P now, okay? It increases by plus 12.5%, and it gives me 19.53. Okay, so how do we do this? Now we can say, okay, this price is P now. I increase something by 12.5%. So your original price is P. We can take that as 100%, which means that 100% plus 12.5% gives us 112.5%. So it means that 112% of P is going to be 19.53. That's the fastest way. See, if they had said decreases by 12.5, we just do 100 minus 12.5. Okay, and then we find the percent that it will be with 100 minus 12.5 in the first place. This is 5, should be 7, should be 87.5 thereabouts. Yeah, 87.5. You mean you're going to find 87.5 of P, but now it's a percentage increase. So we're looking for 112.5% of P. Okay. 112.5%, we can rewrite this as 112.5 over 100 times P equals 19.53. Okay, I'll just ignore the currency for now. So we need to get rid of this 100 and like we want P to be alone here. So what do? We multiply both sides by the reciprocal. We just talked about reciprocal of this so that we can now get rid of it. So that will be, I'll just put it here, times, no, let me put it here. Just write it separately. Okay, this becomes 112.5 over 100 times 100 over 112.5 times P equals 19.53 times 100 over 112.5. Now this 100 cancels this cancels this. 19.53 times 100. So this is something you just, do on your calculator. And the answer should be 17.36. So 17 pounds, 36p. All right, this is your answer. Okay, so this is just like a quick way. Sometimes you could start to say, you could still do something as saying 100% of P, which is the original price, plus 12.5% of P, which is the increase, gave us 19.53, which is 112% of P. 112.5, sorry. 112.5% P is 19.53. Then you just find a P. You change this to a fraction and then you find P, which is what we've done here. So I hope I've made everything like very clear. Um, Hopefully, if you have any questions, please just let me know and I'll be glad to answer them. All right, so let me increase the font of this one. I don't know, at least for number 5 first. Sorry. Oh, wait. Zoom to 100%. Yeah. Okay, this is fine. All right, so Jess saves 2p's, 5p's, and 10p coins. She has four, so you start to write quickly. She has 45 10p coins. 10p's are 45. Okay, 10p coins are 45. Now, 8 times as, so the 10p's, okay, like the 10 pence are 45. 8 times as many 2p coins as 10p coins. So she has 8 times as many 2p coins as it means that she's going to have 8 times 45 2p coins. She has a lot of 2p coins. Okay, 8 times as many 2p coins as 10p coins. Okay. So we have 45 times 8. I'm just going to do this manually. You can use your calculator to do it. Calculator. So this is 40. Um, 4 times 8 is 32. 32 plus 4, that gives us 36. So this gives us 360. So it means that for the number of 2p's, it has 360. There's the eraser. 360 2p coins. And then in total, so they didn't give us the amount of 5p coins. So 5p coins, let's just use X. I think that's a common variable to use. So you have 45 10p coins, 360 2p coins because he has 8 times as many 2p coins as 10p. So what you're going to do is that it means that the 2p coins is higher in number, 8 times higher. All right, so as not to confuse. So whenever you see like you see this, if I say, let's say I have 8 times as many apples as oranges, for example. So it means that if I have 2 oranges, I have 16 apples. Okay, the one that's first, usually the one that's higher in number. 8 times as many apples as oranges. So it means that if I have 2 oranges, I have 16 apples, which is 2 times 8. If I have 3 oranges, I have 24 apples. So you kind of get that idea so that you don't forget, so you understand the lingo. And I have for the number of 5p coins, I don't know is which X. So work out the total value of 2p coins, work out the total value of 2p coins ratio total value of 5p coins. All right. Give you answer in its simplest form. So they didn't even ask us, they just find the ratio. Okay. So what do? We have to multiply. If the total is 17.70, first of all, we multiply 45 by 10p. So let me do that. Let me come down a bit, give some space. Okay. So first of all, we have 45 times 0.10, 0.10, because I'm going to do it in pounds. Okay, 45 times 0.1 or 0.10. This gives us 4.5. So £4 50. Okay, now we have 360 times 0.02, because this is a 2p, so that's 0.02. Now, normally 36 times 2 will be 72 times 0, that will be 3.6. £3 60. Okay, because 360 times 2 is 720. Oh, sorry. That'll be 7.20. Okay, yeah. Divide by 0, times 0.02. And then the last one, x, we don't know. We'll just say x times 0.05. So this will just be 0.05x. So everything here should add up to 17.70. So we keep going. So let's add these ones. So these two, we add them together. So this will give us 11.70 plus 0.05x is equal to 17.70. So we can move this 11.70 to the other side. 0.05x is equal to 17.70 minus 11.70. Okay, so 70 minus 70 is 0. So 17 minus 11, that gives us 6. We have 6 pounds equals 0.05x. Okay, you can do this, you can quickly divide it in a calculator. So 6 divided by 0.05, 6 divided by 0.05, that gives us 120. So it means that in total it has 120. So in total we have 45 10p's. Okay, 45 10p's. It has 362 p's, and then for the 5p's it has 120. 125 p's. Okay, I'm just trying to be slow. Like in an exam, I would be faster, but I'm just trying to explain everything. And then the actual question was work out the total value of 2p coins ratio, total value of 5p coins. So they asked for the value, not the number now, the value. What this means is that we know the value of this, which is 720, 7p 20. The value of 5p coins is actually 6. This one here. So we can actually do, so I just wanted to show you the number, but you can do £7 20 ratio 6. Okay, 7.2 ratio 6. And they asked for the simplest form. Okay. So first of all, I think 6 can go first. 6 here, 1. 1, 6 here will be 1.2. I have 1.2 ratio 1. All right, we have 1.2 ratio 1, which is, I wouldn't necessarily call this the simplest form because we have a decimal. Honestly, when just a decimal, I wouldn't necessarily call it the simplest form. But we need to change this decimal to a whole number. So what number can we multiply to this 1.2 to give us a whole number? It's going to be 5. To multiply both sides by 5. This gives us 1.2 times 5 is 6 ratio 5. So the answer will be 6 ratio 5. As much as this looks like this simplest form, when you talk about ratios, like I know we did this, we did something like this here where they just asked us to do it in this form. For 30 ratio 12, the simplest form will actually be 5 ratio 2. But they asked us to do it in this n ratio 1 form. Okay, for you to get this, the simplest form, both of them have to be whole numbers. Okay, both numbers have to be whole. So the answer here will be 6 ratio 5. All right. Number 6, a part of a regular polygon is shown. Okay. Assume that the polygon is an octagon, so we're just assuming, work out the size of an exterior angle. So what is the formula? So let's remember for the formula for interior angles, that will be, you know, that will be 180, okay, sorry, times n minus 2. right? Or you can write it as n minus 2 times 180. But for the exterior angles, it's different. It's going to be 360 over n, okay? For the exterior angles, 360 over n. For each exterior angle, it's just 360 over n. So right now, work out the size of an exterior angle. So this is just for the sum of interior angles. Sum of interior angles. And this is just each exterior angle. So it said they've told us that it's an octagon. So that's going to be 360 divided by 8. That gives us 60 divided by 8, 45. Okay, 4 45. So it means that each exterior angle, so you have to write something like, okay, um, exterior angle will be, the formula for exterior angle will be 360 over n, and n is equal to 8 because it's an octagon. And then you do 360 divided by 8, which is going to give us 45. So that's the first part. All right. Now this second part, they said, in fact, the polygon has more sides than an octagon. Oh, wow. So they lied to us. I don't know. What does this mean about the size of the exterior angle? Now let's look at it like practically. Okay, we said the exterior angle is 360 over n. All right. And we divided, we got 8. It was an octagon. Initially, we had 8 and we got 45. Now they said this number is actually more. The n that's here, so for 360 over n, this n is actually higher than 8. So it could be something like 9, 10, 11. What does that mean? It means that if the denominator, okay, look at it, if you're doing any calculations and the denominator or any division and there's an increase in the denominator, this number is going to drop. Just also look at it. Let's say 360 over 8, that's 445. Okay, 360 over 9, for example, that should be 40. You can see 360 over 10, that is 36. You can see these numbers are decreasing. As this number here is increasing, this number here is dropping. The value of the exterior angles is dropping. Okay, 45 degrees, 40 degrees, 36 degrees. So there's kind of this is what you call an inverse relationship. All right. So as long as you know the formula, because you know that this is 360 over n, you know that as this n increases, okay, the size of the exterior angle will decrease. So what this means is that it is less than the answer to part A. Okay, the first part. So if the actual polygon was 9, the answer would be 40. If the actual polygon had 10 side, the answer would be 36. So it's less than the answer to part A. So that's just it. Um, so sometimes these questions are not straightforward. They don't necessarily ask you find this or calculate this. They might ask you questions in weird ways where you have to apply what you learned before and stuff like that. So that's it. That's just it. I hope I've been able to explain everything to you well, and see you next time. There's more coming. I think number 7 to 12, hopefully, or if I could do more, sure, no problem.